Our ideas are that we get rid of fractions by multiplying. Other ideas is we can add fractions if we have a common denominator. So we're going to use those ideas together with the following strategy. Just like adding and subtracting, we are going to get a common denominator. So what would that look like in this first one? And I'm going to leave some space. I have 3x, but I'll leave some space. I got 1/4, and I'll leave some space, and I'll equal 3 over x. I have 3 fractions in this question. Can you see that the common denominator for all 3 would be 12x? With the 3 and the 4, it would be 12, and we have one variable x. So my first one, I'm going to multiply by 4 and 4. The second one, I'd have to multiply by 3x and 3x. And the third one, I'd have to multiply by 4 and 4. 12 and 12. That will get every single fraction that I have with a denominator of 12x. I could even add those two together there if I wanted to. This one's going to have a 20 on top. This one's going to have a 3x on top. And this one's going to have a 36 on top. Yes. Now, if you have a common denominator like this, before I do any other math, I can take this and I can multiply both sides by 12x, which would multiply every single term if I distributed. If I multiplied everything, both sides by 12x, can you see that this 12x would cancel out, this 12x would cancel out, and this 12x would cancel out? Brilliant. Why is that so amazing? Because that changes my equation now to just be 20 plus 3x equals 36. And I can simplify this by combining my like terms. And I can solve for x. X becomes 16 over 3. So if we can get that common denominator, we can then multiply both sides by the common denominator, gets rid of our fractions completely, and our life is really easy. So for solving these equations, and these are called rational equations, so we can highlight that. There we go. Take out our highlighter. If you have an equation with rational expressions, it's called an extraneous, it's called a rational equation. One thing you have to do with rational equations is you will have to check for non-permissible values. So in this, the one that we did, the only non-permissible value, the only x that's on the bottom, is x can't equal 0. Was our answer 0? No. So our answer is okay. But sometimes you get an answer that's one of your non-permissible values. Then you have to cancel it out. So let's go to example 1. And we'll go through this strategy. If I can get a common denominator in an equation, then I can multiply by that common denominator, and it will get rid of all of my fractions.
You're supposed to have a red.
No, I'm not. So it's been on mute. Thank you for noticing. So the intro was nice and silent. Okay? But now, excitement will start to build in the video. Right? So, the main strategy is get a common denominator. So at A, I'm going to leave some space. Can you see what a common denominator would be for all three of these? The number would be 10, right? 10. And the variable would be x. So the first one's missing a 5 and a 5. The next one's missing a 2x, because you can multiply by 1. And the last one already has a 10x. I don't even have to multiply anything by that. So what do I get? I get 5 over 10x minus 4x over 10x equals 1 over 10x. And the whole purpose of this, of getting a common denominator in an equation, because what you do to one side of the equation, you do to the other. So now, on this side, I'm going to multiply by 10x, and on this whole side, I'm going to multiply by 10x. What would that do? Well, on the right-hand side, that will just cancel out. On the left-hand side, when you multiply that whole side by 10x, it would get distributed to each one of those. And every time it gets distributed, those will cancel out. Which is really nice, because you take what was initially a complicated equation with fractions, and it becomes 5 minus 4x equals 1, an easy equation with variables. Do I have like terms? Yes, so I can move my 5 over, negative 4x equals negative 4. Divide both sides by negative 1, and I get x equals 1. What was my non-permissible value? My non-permissible value, x can't equal 0, so this is okay. Perfect. When we look at part B, same thing. I'm going to rewrite it and leave some space. So part B I'll do here in blue. I have 5 over x, leave some space, plus 6 over x squared, leave some space, equals 6, which is technically 6 over 1. What's my common denominator going to be? X squared. So the first one needs an x. The second one has it already. The last one needs an x squared. I'll have 5x over x squared plus 6 over x squared equals 6x squared over x squared. And at this point, if you want to show your next step just like this, because you could multiply both sides by x squared, which would brilliantly get rid of all of your fractions. You'll sometimes see on, like if you look at people doing this online or sometimes in the textbook, sometimes they multiply by different things to slowly get rid of the fractions. I find it's easiest if you get that common denominator first, then you're just multiplying by one thing to get rid of all of them. That's going to be the easiest. And now, we would have 5x plus 6 equals 6x squared. What kind of equation is this? Quadratic. How do we solve quadratic equations? Either with the quadratic formula or factoring. But we do need to make one side equal to 0 first. Does this factor? I think so. I think so. Look, if I do 2x and 3x, and if I put a 3 here and a 2 here, my outside is 4, my inside is 9. And if I had minus 9 plus 4, that would give me minus 5. Multiply it out to check. Sure enough, it works out perfect. Okay? Now, again, if the factoring on this one, because this is a harder factoring one, if you're stuck on that, go to your quadratic formula. Your quadratic formula will give you exactly the same two answers. That x is equal to 3 over 2 and x is equal to -2/3. What was our non-permissible values? We're only dividing by x, so x can't equal 0. So both of these are fine. And both of them work. Questions to circle on this one?